Hey everyone, and welcome to the first episode of Mrs. Ross Does Math. Our lesson today is for Math 8, and it is on special quadrilaterals. This is lesson 13. Today I'm going to begin by going over our notes, and then I will go ahead and do a couple of introductory problems with you, both as examples and a lead-in into your assignment that I would like you guys to give a try. So once again, this is lesson 13, special quadrilaterals. Our essential question for this lesson is, how can I find the measures of angles in parallelograms and isosceles trapezoids? Now, in order for us to be able to find the measures of angles of parallelograms and of isosceles trapezoids, we have a couple of vocabulary words that will be really critical. The first is a parallelogram. Now, a parallelogram is a quadrilateral with two pairs of parallel sides. What that means is that we will have a four-sided figure. That's where we get the quad from. Quad means four. So a four-sided figure. And in this case, we have two pairs of parallel sides. Since I have two sets of parallel sides, I am going to have parallel line indicators. And that is what these arrows are. Since these arrows here both are just one, that means that this line and this line are parallel. Because these on the sides have two parallel indicators, that means that they are a pair of parallel lines. Now, knowing that is going to come in handy when we get to the piece where we actually need to find the measures of angles. Now, the other type of figure that you're going to need to know is what's called an isosceles trapezoid. A trapezoid in general is once again a quadrilateral, meaning a four-sided figure with one pair of parallel sides. Because the types of trapezoids we are going to be working with are isosceles, that means that they will have two sets of sides that are equal. Here we have our parallel line indicators, and over here on the side, because these are isosceles trapezoids, our two segments on the side are going to be equals to each other. So whatever this side equal is, whatever this side is, this side will equal. Again, that's because the types of trapezoids we will be working with are isosceles trapezoids. And once again, those have one pair of parallel sides, and they have two sets of sides that are equals to each other. Just like I talked about up above, an isosceles trapezoid is a trapezoid with a pair of congruent legs. Now remember, the word congruent means equals to. So when I talk about my figure, this is what it will look like. I have my parallel lines right here, and my congruent legs are on the sides. This section here is a leg, and this section here is a leg. And once again, because they both have a single congruency mark, that means that these two legs are equal to each other. So, moving into our information, we have a couple of different properties that we're going to be talking about. The first property is related to parallelograms. Sorry, that's my dog's tags jingling in the background. So, properties of parallelograms include the following. When we talk about a parallelogram, and again, a parallelogram is a figure with two sets of parallel sides, the opposite sides are congruent. So going back up to our figure on parallelograms, by having these tick marks or these parallel marks, that means that this line is equals to this line. And over here, because these have 2, that means that those segments are equals to each other. So if this is 4, that means this piece down here is 4. Over on the side, if this is 2, that means that this side will also be 2. Okay. Next, so the opposite sides are congruent in a parallelogram. Now, the opposite angles are congruent as well. So, keeping that in mind, going back up to our figure, again our parallelogram, because these 2 sides are equal, these big angles here in the corner are also equal. Now I'm going to mark these as angles with a single angle indicator. Now, just like my other corners here will also be equal. And because these are also equal, I'm going to mark them with 2 angle indicators. So that means that this angle down here is congruent to this angle here. And this angle here is congruent to this angle down here. So once again, a parallelogram has 2 sets of parallel sides, and the opposite sides are congruent to each other, just as the angles are congruent to each other. Now lastly, we have something called consecutive angles are supplementary. Okay, so we've talked about consecutive angles before. You guys know them as same side angles. So thinking about this, if I have a figure, and I'm going to draw this over here on the corner, let's say I've got my 2 sets of parallel lines, and it's cut by that transversal. Okay, what that means is that this angle here and this angle here, those angles add together to give us 180 degrees. Now, if we were to imagine this as a parallelogram, cutting this off down here, these 2 angles once again equal 180, and that means that this angle, I'm going to mark this one as X, and I'm going to mark this one as X. These 2 angles also equal 180. So those sections of angles are supplementary. Oh, sorry, sweetie. Okay. So keeping that information in mind, we are going to go ahead and proceed with an example problem. Now in our example, I have this parallelogram. My parallelogram here says find x, y, and z. Now I'm going to begin by finding x. Now x is this upper length segment here, and since this segment here is congruent, meaning equals to the 11 on the bottom, I'm going to set them equals to each other. So to find x, I'm going to write 2x plus 1 is equals 11. Now from here, we're going to solve it. I'm going to minus 1 from both sides, giving me 2x equals 10. I will then divide by 2 on both sides, giving me x is equals to 5. What that now means is that if I was to plug the 5 in up here, I would get 11 up top and 11 on the bottom, which is exactly what I want because they are a set of congruent sides. So I'm going to circle this because we have found our x. Next, if we go to our x and our y, or sorry, the y and the z. The y and the z are both degrees. So whatever we have for our final answer, we're going to need to include that degrees notation. Now, y and z are opposite of each other. meaning they will be congruent angles. So whatever I find out for y, that's going to be z. And whatever I find out for z, that's going to be y. Now, in a parallelogram, we know that angles that are on the same side have to add together to be 180 degrees. So what that means is that if I'm finding for z, z plus 33 is going to equal 180. Now I could use this to now find out what z is. So I'm going to minus 33 from both sides, and that's going to give me z is equals to 147. Now, I'm going to put my degrees notation there, so z equals 147 degrees, and I'm going to circle it. Next, we are going to make a statement. Our statement is going to say angle y equals angle z. And over my equals, I'm going to put our little tick mark, or sorry, not a tick mark, our little congruency mark. So now that means that so here, angle y is congruent to angle z. Now because angle y is congruent to angle z, angle y is equals to 147 degrees. So we don't even have to go through and create an equation for angle y. All we need to do is state that angle y is congruent to angle z. And again, they're congruent because they are in opposites of our parallelogram. So because they are opposites in our parallelogram, they are congruent to each other, and therefore angle y is also 147 degrees. Now, if you have any questions about this example, please leave me some comments down below. Please pause this video and re-watch any segment that you may possibly need. Now, just as how parallelograms have properties, trapezoids also have properties. So, like I said before, we are going to be focusing on properties of isosceles trapezoids. So, when we talk about an isosceles trapezoid, the legs are congruent. Each pair of base angles are congruent. And the top angle and the base angle are supplementary, meaning they add together to give us 180 degrees. So, if I were to draw a little figure, and I'm going to have to draw my figure over here on the side. Okay. My legs are congruent. So this is my leg, and that is my leg. Those are congruent. Next, each pair of base angles are congruent. When we talk about the base, we talk about the bottom of a figure. So that means that this angle here is congruent to this angle here. Next, the top angle and a base angle are supplementary. So that means that this angle plus the top angle here equals 180 degrees. So once again, the angle on the bottom and the angle up here equal 180 degrees. They are supplementary. So keeping those properties in mind, we are going to move into our second example. Our example says to find A, B, and C. You'll have to forgive me as I'm still figuring out where all this is going to go. Okay, so here we go. So we want to find A, B, and C. Okay. So with this, we are first going to begin by finding B. That's going to be a lot easier for us. Once again, in an isosceles trapezoid, our two leg segments are congruent. They are equals to each other. So I'm going to begin by setting 15 equals to 3B. So 15 equals 3B. And again, I'm setting those equals to each other because this leg, my 15, is congruent to this leg over here, the 3b. And congruent also means equals to. So now we're going to go ahead and divide by 3 on both sides. And we're going to be left with b equals 5. And we're going to circle it. Next, we're going to go ahead and process what A and C are. Now, A and C are the top, the 76's in the bottom, or the base. Now remember, each pair of base angles are congruent. That's why these are both 76 degrees. The top angle and the base angle are supplementary. They add together to give us 180. So, to find A, I'm going to go A plus 76 equals 180. Now, I'm going to subtract 76 from both sides, and that's going to give me A equals 104 degrees. So I have now gone through and found what A is. Now, because we have an isosceles trapezoid and our two legs here are equal and the two bottom angles are equal, our two top angles are also going to be equals to each other. Now, we can go just like we did before by stating angle C is congruent to angle Z, but that's not up here in our property, so we can't always make that assumption. We could because these are isosceles trapezoids, but we aren't always going to have those, so I want you guys to know how to find that in case we don't have an isosceles trapezoid. So, we're going to begin with going C plus 76, once again, is equals to 180. So C plus 76 equals 180. We're going to minus 76 from both sides, and we get C equals 104 degrees, just like we did with the other. So C is equals to 104 degrees, A is equals to 104 degrees, and B is equals to 5. Now again, if you guys have any questions about this at all, please leave me a comment down below. This is brand new to all of us, and we're trying to figure out the kinks and what's going to work and what's not. So please leave me your feedback. If you need additional example problems or warm-up problems, I'm happy to provide that for you as well. Okay. Now today, in your assignment that you have, we are going to go ahead and complete number 1 together, and we're also going to go ahead and do number 5 together. Okay, 1 and 5. So I'm going to go ahead and scooch this out of the way, and here we go. So this is your assignment, Math 8, Lesson 13, and once again our topic is special quadrilaterals. In these figures, I'm asking you to find out what the value of x and what the value of y are in each figure. Excuse me. Now, in this figure, once again, always please begin by writing your name, the date, and the class period. Okay, so to begin with our properties of an isosceles trapezoid, which is what figure 1 is, the top and the base add together to give us 180 degrees. These add together to equal 180. So, to find my y, I'm going to do that. I'm going to go, in this case, 102 plus y equals 180. I'm going to minus 102, giving me y is equals to 78. And again, y is a degree, so I'm putting the degrees notation. That's it. Now, for x, once again, these are adding together to equal 180. So, I'm going to go 78 plus x equals 180. I'm going to minus the 78, and that gives me x is equals to 102 degrees. So now we have gone through and found out what the values of x and y are in our figure. Now, you don't always have to find x first. Sometimes it's going to be easiest to find y first, and that's totally okay. All right, so here we go. Moving on, I said we'd also do number 5 together. Okay, so number 1 is a trapezoid. Number 5 is a parallelogram. Okay, so here we go. So in number 5, when we talk about a parallelogram, we talk about our sides being equals to each other. So this side, my 4x plus 3, is equals to the 19. So I'm going to set that up. I'm going to go 4x plus 3 equals 19. I'm going to minus the 3 from both sides, giving me 4x is equals to 16. I'm going to divide by 4, and that's going to give me x equals 4. Now, I'm going to circle it, and there we go. The x in 4x plus 3 is 4. Now, I can double check this by plugging it in, and I can go 4 times 4 plus 3. 4 times 4 is 16. 16 plus 3, that does give us 19. And that's what this side should be, because once again, they should equal each other. Now, just as how in a set of trapezoids we have a set of supplementary angles, we have the same thing here. The 25 and this empty space up top add together to give us 180 degrees. So, what I'm going to do is find out what this should be. Now in that case, 180 minus 25 gives me 155. So that means that this little corner is 155 degrees. Now in a parallel or in a parallelogram, my opposite sides are congruent, and my opposite sides here are congruent. So that means that the 155 up top in this corner is the same thing down here. Now we could also prove that by, and I'm going to use a different pen for this, by assuming that this pair as well is also supplementary. So I can also set it up as y plus 25 equals 180. We can minus the 25 from both sides, giving us y equals 155 degrees. And again, we need to include that degrees notation because it's a degree. Otherwise, it's just a number. All right, so what I'm going to ask is that you guys give this assignment a shot. Again, if you have any questions at all, please leave me a message in the video comments below. Please send me a message through Remind. Please send me an email. I want to help you guys out with this. So once again, if you have any questions at all, please contact me. I'm always here and available. Thank you so much for watching. This is Mrs. Ross Does Math.